Hello everyone. Today we will have the second webinar of a series presenting what's new on CATIA Design for the R2019X release. For today's webinar on surface refinement, I am very glad to welcome Xavier Melconian, who is responsible for the product and portfolio definition of CATIA Design. As usual, the recording of this webinar will be published in the CATIA user community. Don't hesitate to ask us questions and we will answer you. You can also write to katia.contact@3ds.com if you prefer an email response. I leave the floor to Xavier now and wish you a very good webinar.
Welcome and thank you for joining this session about what's new in the 3D Experience 2019X for design and styling. This is the part 2 talking about surface refinement. So with the CATIA Design and Styling portfolio, we address the user community of the creative designers, the surface modeler, and the decision makers with physical and virtual prototype in multiple industries, from transportation design to product design. What we want to reach is to help this user community to develop their creativity and innovation, but also to reach high level of surface quality, up to Class A quality and perceived quality, and also to help the design studios to accelerate their design process to take quicker and better design decisions. In addition to that, there is another trend that we want to address is the move of the edge of the experience. We want to help the design community to design their product, but also to design their consumer experiences, and that with the 3D Experience platform. All right? So we have a rich portfolio, and today we will focus on surface refinement, so the portfolio for surface modeling. And for that, I am with Laurent Garza, who will explain us what is, first of all, the surface refinement topic.
Yes, of course, Xavier, thank you. So surface refinement, as you know, the challenge is to provide for production engineering department high-end quality surfaces that match both aesthetical and manufacturing constraints. Of course, the challenge is to provide this with productivity because it's a very long shot work. So, of course, the value we propose with our solution is to bring more productivity and also innovation in this domain.
Okay, productivity, innovation, quality. Excellent. And in surface refinement, you also cover reverse engineering to start from the scan?
Yes, because quality also starts with the construction from mock-ups. So we really want to automate as much as possible this process, which is today costly to the customers, and make sure they can improve it also in the very near future.
Starting from the physical prototype to scan it and to do the reverse engineering.
And to provide at least offsetable surface as a first shot.
Okay, so let's see a customer in action.
Yeah, sure.
It started as a design study to imagine a lawnmower of the future. Usually, I start drawing a two-dimensional sketch, and then I import it into CATIA using Sketch Tracer. If the shape is organic, I use Imagine and Shape and make it a solid with part design. That is my usual workflow. Modelers, designers, testers, and many others are able to collaborate on a common design through the use of the 3D. I think that is a major benefit of the platform.
By sharing a common 3D model, designers can express their diversity in design, whether it is a reflection of their distinctiveness experience or technical level. We can look at the same design using different perspectives, with a new personality or perspective added to it, and we can see the impact of changes to the design working on the same platform. I think that adds to a broader scope of design.
As a digital modeler, it is my role to understand the design intent and what the designer wants to express through a sketch. I can check a model right away with a designer using virtual reality. Sometimes it's to check if everything will fit into the given space, or to check if the size is accurate. We may also ask engineers to join us to examine how easy it is to maintain the products, for example. The 3D Experience platform is very useful for us.
Wow, that's very impressive, Laurent. So can you tell us what's new in 19X?
So 19X is a very important release for us because, as I mentioned, we continue to deliver more and more automating tool inside the reverse engineering portfolio.
Okay.
So many new things in this aspect that we will see later on in detail. As usual, we deliver a lot of new capability, again, for productivity in CATIA Icem and freestyle applications.
Okay.
And the big news for 19X, of course, is that we deliver a new application called ICEM Design Experience, supposed to give a bridge between concept modeling and Class A by giving new tools, new user experience, productivity, and collaboration capabilities to speed this job and accelerate the Class A delivery.
Excellent. That sounds very promising. So let's go into the details.
Yeah.
All right.
Sure.
Thank you.
Thank you.
So concerning reverse engineering, we continue our strategy to automate as much as we can the process of reconstructing the surfaces from a mesh or a scan. The objective being at each stage of this capability to really give control to the user even after automation to make sure you get the good quality at any stage of the process. Okay, so as a quick overview of the 19X release new capability, first, in the digital shape preparation application, we have extended the check and repair capabilities in the mesh preparation command. If your scan presents long gaps, you have a stitching mechanism which was not available in the previous release. That is saving a lot of time to get better scan, to improve your scan against 3D printing purpose or even reconstruction later on. Today we're going to focus mostly on the digital shape to surface application for reconstruction with the contrast map, the fictive edge new command for this character line materialization, and the mesh shape analysis improvement. So contrast map and fictive edge. So contrast map is a single command, but it's also embedded inside the fictive edge command that we are using here. And of course, at a glance, you can really see, understand the mesh with where are the fillet, what are the character line, and also what is the quality of the scan. So here quickly, you can just by a simple pick onto the fillet itself, provide construction section from which we're going to obtain actually the character line, fictive edge in French. Okay, fictive means it does not exist. Still, you can deduce it. By construction, this kind of shape is really smooth. Okay, you can see that here naturally I have a very good curve, even if my borderline here, which are used for reconstruction, are not so smooth. Okay, so I can do pick workflow here, but if I am using previously from the fictive edge command, I can really use a curve onto the scan itself. So here I am using curve network preparation. I can do a curve actually laying on the scan. Okay, you can see that I'm not so accurate in being onto the fillet itself. Still, I'm going to be able to use this curve as a quicker indication for my fictive edge. So now I am going to the fictive edge command. I click onto the curve, and directly my fictive edge is popping up from the point of the previous curve. Of course, at each of those points, I can manage the section itself, the radius of influence. You can see that already I have a good curve. Still, it seems not to be so accurate against the fillet. So I can add one section here on the fly, for instance. And I can see that maybe my sections are not so exact because I have a very thin flat area between the two fillets here. Okay, so I'm repositioning my influence radius and the borderline at the right place to have the right place on the fictive vertex of the section, like here. And you see that the curve is slightly moving. It's correcting it. Okay, same here. My curve is better and better. Here I'm a bit onto the fillet, so I'm going away. Okay, and I of course can manage things in an asymmetric way. So if I found that the other borderline is too far from the fillet so here I'm going away from the fillet. On top, it seems I'm too far, so I can make some points in the better position. So when I have tuned my section like this, I can see I have a very good curve against the scan. Okay. We've been improving also curve network preparation, because here you can see we have two character lines that obviously are not exactly on the mesh, they are away from the mesh. Still, in the curve network preparation, you are able to use the connect command to connect them with a good quality. Okay, even if it's not projected onto the mesh, you can still use this command for the fictive edges. Last but not least, if you create, for instance, a 3D curve from a freestyle on CATIA Icem onto the mesh itself, okay, you are also able to provide it to the fictive edge command, and in one shot you get a very good, very long fictive edge here. Okay, so that's the three methods basically to get a fictive edge. So if we summarize, we provide in Nginx a contrast map to be able to judge the scan, not only from the shape, but the style, where are the styling features, where are the character lines, and of course also judge of the quality of your scan, which also again is a good information to know where you should pay attention or where you can ignore the problems. We provide the character line materialization command called fictive edge to do the curve instead of having to do the fillet ribbon. And those curves are able to be managed by the curve network preparation command and the curve network, which allows you to generate the sharp surface network from the scan. Now let's see the mesh shape analysis improvement. So in Nginx we deliver this capability of providing a color map in an automatic way from the scan. So the system here is, with the refined level I have chosen with the slider, is able to propose to me first zoning based on some curvature criteria I don't need to know. And from this proposal, I'm able to refine it by merging some zones, like I'm doing here and there. But I'm also able to resplit some zone if I don't find them accurate enough. But you can see that when we use an actual scan, the limit between the zones are not always ideal. Okay, so here I'm doing I would say my micro zoning, merging the little zone together. But then when I'm done with my rough micro zoning, I really want to refine the boundary of those zones to make them more clean, okay, cleaner. So here, typically, I know it should go straight. So I'm using this brush option now we deliver in Nginx GA to fix this boundary area. Okay, and here it's much better. So obviously it is somehow an expert tool, because it means people using it know in advance, I would say, where the limit should be and how they should be. It means you need to have an expertise on the shape and being able to really understand the design intent here. Okay. So you can see I can refine this area here. Same, I think it should be straight from the arch wheel up to the character line, the top character line. So I'm using the brush to divide the parasite zone, I would say. Okay, here I can merge it. And same here, I'm going to cut the blue surface, blue zone in two, thanks to this brushing movement. And when done, I'm able to merge it into the purple area and get the actual limit I was expecting. Okay. So after a while, you are able to do that for the whole car, okay, and get a much more accurate zoning than the one you have just by merging zones, okay. This capability mesh shape analysis that was delivered already last year has a huge value, even if it's not very obvious for now. Why? Because first, it's allowing you to understanding the mesh shape and the styling features in a complementary way from the contrast map. It's a very important tool to communicate. So if you want to communicate with the creative designers, with the clay modelers, even with people from downstream process and from engineering and feasibility, this color map can be a great media to discuss and even to annotate. Okay. Keep in mind also that people doing the mesh shape analysis might not necessarily be the people doing the reconstruction. It can be different users. So this tool can show guidance to the guy in charge of doing the curves and the surface network in the process. And why this tool is strategic for us, it's because it will be used in the near future to automate the curve generation. Okay, so stay tuned. Within the next year, we'll probably have a tool to do that. But so it means this tool really need to be consolidated. This is why we improve it since it's out in 18x, to make sure you quickly are able to describe this color map and make sure we can exploit it to do curves. That was it for 19x GA. Thanks for your attention. And now let's switch to surface refinement.
So now let's move to CATIA Icem with Fabio, maybe?
Yes.
Okay.
Okay. So with CATIA Icem, as you know, we want to provide the best-in-class solution for dedicated to surface refinement and Class A. The idea is to unify the power of the associativity with the precision of direct modeling and sculpting and the flexibility of the subdivision surface. And of course, as all that is included in the 3D Experience platform, we want to streamline the design engineering collaboration. So, as I said, we combine the explicit and the associative, so differing way to create geometry. But we also provide some specialized feature dedicated to Class A and also for analysis check, okay? And of course, we guarantee a bidirectional link between ICEM Surf and CATIA Icem. So in this example, we want to show a typical phase where the user add many intelligence behind. So we have a lot of associative features that are related to a single surface. So it happened in the past to reach such a kind of stage like this where the performances slow down. So in this case, we have enhanced this behavior by just providing a new mode, which is the static mode. And you see how the experience of the user in the modeling has been improved by just, we release, once we release the movement, the update starts. So the idea is really to have a smooth control point movement instead of sticking control point movement. And with this enhancement, we really reach this level.
In this example, what we want to show you is also the mindset of the computer-aided styling modeler and the Class A modeler. They are not function-driven. They are shape-driven in their mindset. So it means that they need to play with the shape and the surfaces. So even the user experience is important for them. So when they are playing with the control point, if they have to wait 2 minutes of an update of the system to see the shape, it doesn't work for them. They really need to have a kind of interactive user experience while they are doing some shaping or sculpting of the surfaces. Okay, so this is what we're doing with CATIA Icem, and now we want to reach another level of user experience for this profile of users, and that's why we are introducing a new application called ICEM Design Experience, which is a new generation of surface modeling for computer-aided styling, CAS, and Class A surface modeler. So a dedicated user experience for these people and this way of thinking. And Laurent, maybe you can tell more about ICEM Design Experience?
Yes,
which will be available, by the way, in which role?
So you will retrieve this new application on 19x in Transportation Designer and Class A Modeler roles. Okay. So this is some time now we are working on this application. The objective was really to deliver a new level of productivity, also innovative tool, and ease the collaboration for CAS and Class A Modeler. We have been studying a lot user experience here to make sure we satisfy those users that so far are more using ICEM Surf than CATIA actually in their daily job.
And ICEM Design Experience is on the 3D Experience platform.
ICEM Design Experience is I would say, the missing bridge between creativity and Class A job, detailed job we are doing with CATIA Icem, as Fabio was showing, on the 3D experience, of course. And so this is on 3D experience. It is really user-oriented, so we really thought about the way people are working daily, of their efficiency, and it's really fitting in the existing roles because, as I say, it was a lack so far to be able to be more efficient in modeling. But it's also very important for the collaboration continuum, so not only the geometrical continuum, but also the team efficiency, because we can bring the whole population of ICEM Surf user onto the platform right now. So they will retrieve kind of tools they like in ICEM Surf on the 3D experience also.
And the particularity of this project, because it's a new, not a new project. In fact, we have started several years ago.
Yes.
But we have, since the beginning, we have faced some new profiles of users. So the project has evolved over time.
Exactly. So to be clear with you, this first release is a minimum scope for ICEM Design Experience. Of course, we still have many years in front of us to enrich the scope that is very huge. Because at the beginning of the project, to be honest with you, we were targeting mostly ICEM Surf users, but working with some customers, we saw that there are 3 categories of users. You have ICEM Surf users that we want to bring in 3D experience. We have also some CATIA users, so it's various populations, some guys from engineering coming to the studio, some people starting to use CATIA Icem since 2 or 3 years, so they already know CATIA. We have to take those guys into consideration to make sure they also feel at home in this new experience. And last category of user, which is not so common but existing, which we call morphing. So those guys are mostly working with swept surfaces that they deform. They do use a lot of global deformation to come and map the clay model.
So with this project, in fact, we discovered several methodologies to do CAS and Class A modeling. And based on the customer relationship we have with these guys, with this customer, in fact, now we have to address these three profiles of users with this application, which is pretty challenging, but we're on a good track.
Yes, in other words, we have increased the ambition of this application for targeting more population than planned initially.
So it takes more time.
It will take more time because, again, many releases coming with new capabilities too.
So what it means, technically speaking?
What it means, technically speaking, is we have totally revised the modeling approach. So to make sure people are able to do direct modeling, okay, just like they do today in Imagine and Shape. You see a shape, you directly get access to modeling tools, you deform it. Of course, we want to keep surface control in parallel of modeling approach. Yeah. So at any time, you can, like you are doing in CATIA Icem or GSD, get Bezier, get NURBS. Okay. No limitation in the mathematics you are using.
And 2 cultures of people that we want to address. The people who are used to ICEM Surf to do surface-based approach of modeling, and others who also want to do curve-based approach. They start by curve and then they generate the surface. So we have to face and address these 2 kinds of populations also.
Yeah, it's traditional methodologies, I would say.
People who like to work in NURBS, others that prefer to work in Bezier. And what's new also is the parametric approach.
So what's new, and today it's not open yet on the 19X because we have restricted it to explicit modeling, but what's clearly the promise of this application is to offer what we call soft parametric. So soft parametric is a way to tune the behavior for a user between not update at all and full update like you know today in part design or GSD features. We will come back to that later on. But this is the big promise so that any category of user we were mentioning before is able to have the behavior he wants while he's modeling his surfaces. It will be more concrete with some demo.
So a lot of new things.
A lot of new things. I won't go into detail, but on the 3 capabilities: productivity, innovation, and collaboration. One small word on innovation that you can already test on the 19X is we don't offer only Bezier control point. We offer a new deformer for the surfaces, and as of today, we don't have any user using that because they don't exist in competition software. So we expect from the field to get feedbacks on how people are discovering the tools and how they are using it. So Fabio will demo that in a moment.
So, just before going into a complete workflow, I'd like to show you in simple examples some of the concepts we already mentioned in the previous slide. So first of all, we decided to integrate ICEM Surf Navigation inside this software. So now you can choose between CATIA and ICEM Surf Navigation. And this was to help people coming from ICEM Surf World to feeling home. Okay, so you see this is actually the ICEM app. You also saw the VNav on the right top. So it's a gizmo that you need to navigate better and so on. So you see here, we also improved the selection, but one of the principles very important in this application is every single interaction has been defined by the 80-20 rules. As you see here, we get access to the command that are used 80% of the time in a very quick way. So you saw actually that while I was creating a surface, I was actually also having access to control point very fast, and also access to analysis. Another concept here is the Omni technology. So we decided to have one single command to create every kind of surface. And as you see here, there is a decider that helps the user provide the shape he wants based on the selection. So this really helps improve and enhance the workflow, because the user has no more to ask himself what kind of surface I'm going to create. He just select the inputs that he needs, and the decider will help him and will assist him in providing several kinds of surface. So just show with the same command we are able to create blend type curve, blend type surface, pass from curve surface, sweep surface. Okay. We also notice that my mouse stay on the center area of the screen, really in the 3D. So we made a huge effort by reducing the mouse miles and having access to the command just under the mouse, and do not deviate too much the concentration of the user around the peripheral area of the screen. Okay?
So the big new paradigm, if you go back, is to be able at the same time to create the surface and to sculpt it at the same time. Again, the guys are working on the shapes. Their job is to define and find the right shape. So at the same time, the system is generating the surface for you based on your selection, but at any time you can play with the control point to continue to sculpt it. Okay.
Yeah. And the idea is really to get access to this tool without search for the command.
Some innovations?
Some innovation here. Yeah, you see the way we select here, and one new concept is the universal law. So you see here we can manage a posteriori the way we want the shape to be deformed, and and as Laurent mentioned, we also provide several ways to deform the surface. So you see here we have a Bayesian mathematics surface, but we can modify it through gravel point, global point, and of course the natural control point from Bayesian mathematics. You see here I use massively the action pad to get access to the function. I just created a match. And another way to deform this surface is the torque handle, which is an innovative technology that we have integrated and extend in 3D here, which is coming basically from the 2D graphic design. We decided to extrapolate this concept for the 3D environment, and this really helped us also deform this mathematics Bayesian in this case. So now let's go in a more complete workflow. You see here we get access to the analysis in very few instants, I would say very fast. We also see again the universal law, how we manage the propagation of the deformation of this surface in order to adapt the sculpting we are doing today. You see that I have access to the control point in any time. You don't even see that I'm going to a function. I just activate with the gesture menu, mouse menu, very easily such a kind of functionality. Again, I can play both on parameters on the fixture on the top right here, but also going through sculpting and mix these two paradigm. Okay, we really do want to have no boundaries between parametering and sculpting. Okay. Again, access to the analysis. Once more, and again, access to the, I would say, the decider I just mentioned, the Omni technology. So using the same command, you see here, the user just select the input and the system provide a result, okay? By the same principle, I am able to create all kind of surface, like the fillet here, and going up, refine and create geometry without thinking about the technology behind. The idea is at the end of the creation of the geometry, we access to the standard analysis tools to measure the quality of the geometry, here an example. But at the same time, we still, as we are in the 3D experience platform, have access to all the functionality of the platform. So in this case, I'd like to retrieve one interesting functionality, which is the gap command from CATIA Icem. And of course, everything has been streamlined and connected all together. So you get access to the full capability. And another example here is the high-end visualization from live rendering. By just click on a button, I'm able to create a physics realistic image like this one. And why that? Because now we consider that the visual experience is really part of the modeling. So as soon as we have a great experience visually, we can really appreciate the quality of the shape that we are creating. Okay, so in this case, you see an light analysis. So we simulate what is physically is done by putting the car in a tube or the car in a hanger and see how the reflection in the highlight behave on top of the surface. Okay, that's pretty much it for today for the demonstration of this new exciting app that is going to the market. And
okay,
let's see.
Let's move on. It's not finished. Can you go next? Thank you, Fabio.
Thank you, Fabio. So as I was mentioning, on this GA you have the modeling approach and surface control that are delivered to you. The soft parametric will be for the next release actually, but I'm going to say a word on that. So basically, what you need to understand is an ICEM surf user is used to explicit modeling, so no associativity at all. CATIA user is used to full associativity. Morphing guys are in between. Okay, they like to have features to generate shape, and they have no associativity to deform them. So basically, in the soft parametric, what it means is that you will have different update mode and behaviors that you can tune, okay? To go very quickly, inactive is a feature that does not update unless you ask him to do. Alert is the same, but it's just giving you more analysis, like, hey, I'm broken, think about me. The adapt mode is, I would say, the marshmallow mode. It starts to match surfaces together with minimum moves, so it will be very useful for morphing guys. And we'll have the rebuild and reshape mode, which is basically behaving like the feature modeling of CATIA Icem. All those modes are will be differently used depending on the user population taking hand on the ICEM design experience. Okay.
So giving the full flexibility from the user to tune the level of associativity and parametric he wants.
So this is a very important promise of the application that you have to remember when you explain that to the customer, because as of today, as I explained to you, you have only the datum mode, like ICEM Surf for the first release. This is coming next year. Okay, this is a big promise.
Which is, by the way, unique on the market. Huh?
It's unique on the market, and probably it will also bring us to a new methodologies and new workflow. So
okay,
we have to still keep on with customers to make that progress.
So that's for ICEM Design Experience. So it's the first release of ICEM Design Experience on the 3D Experience platform that is available in GA in the 19X release. But there will be more things coming in the FDs, in the maturity will evolve over time. Okay, it's a first drop.
On-premise and on cloud, both.
Yeah.